Okay guys, welcome back to another episode. So we're going to be talking about three variable systems and solving them today. We're going to be using a method called substitution, and these are going to be our steps for solving these problems. So we're going to be given three equations with three unknowns, usually represented with x, y, and z, and we're going to be asked to solve these equations for all three unknowns. So it's kind of like in Algebra 1 where you solved an equation for one unknown. We're going to be solving three equations for three unknowns. So if we look at these steps, first thing we're going to do is we're going to take one of the equations and we're going to solve it for one of its variables, and we get to choose. And I'll show you that here in a minute with an example. Step 2, we're going to take that solved equation and we're going to substitute it. That's where we get the name substitution from. We're going to substitute it into two of the other equations. And then we're going to solve those two equations for those two unknowns. We'll look at this here in a second, but one thing to realize is we do have some special cases. Anytime we get an equation that's not true in any of these steps, like 0 equals 1, if we got something like that, we would say that the system has no solution. And then if we got an identity where that would be kind of unhelpful, like if we got 0 equals 0, we know that, we know 0 equals 0, well, we want to know what x, y, and z are. If we got something like that, then we would say that the system has infinitely many solutions. Infinitely many solutions. But let's, and if you want to take these steps, put them into your notes, write them down somewhere so that you can refer back to them. And we're going to follow these steps now to solve a system of linear equations. So here we go. Here's an example. We have these three equations, and we are going to solve them for x, y, and z. So step 1, we're going to pick one of the equations and solve it for one of the unknowns. And what I would do, guys, is I would pick one of the equations that has a variable all by itself without a coefficient. So for example, the second equation, the x is all by itself, doesn't have a coefficient, and the z does as well. So I would solve that equation for either x or z. Let's solve for z. Again, it doesn't really matter, but let's just solve the second equation. So I'll tell you what, I'm going to write the second equation in blue, okay, so that we can keep track of that. Second equation in blue. So let's solve that for z. Let's solve for z. So we could subtract or add the other terms over to the other side. So we'll have negative 6 on that side, and then we want to subtract x, right, because we moved the x over, and then we want to add 3y because we added the 3y over. Okay, and so that equation is solved for z. Now we can take that value for z, this right here, this expression for z, and substitute it into the first equation and into the third. So let's substitute it into the top equation first. We'll put that in red. All right, I'm going to give myself a little more space here. So let's do this, substituting that in for z. So we'll have 2x plus 3y minus, and then all of our z, which is negative 6 minus x plus 3y. Okay. Now we can distribute that minus. So what's going to happen is it's going to change all the signs of everything in parentheses. So we're going to be left with, if we distribute that minus sign, it's going to turn into a plus, that's going to turn into a plus, and this one's going to turn into a minus, right? Okay, so when we distribute that negative, that minus sign, it changes all the signs of all the terms. Okay, now let's combine terms. We have a 2x and an x, so that combines to be a 3x. And we have a 3y and a negative 3y. Those actually cancel to be, oh, and I forgot. All this is equal to, look at that first equation. All this is equal to 9. Okay. So we have a 3x and we combine the 2x and the 1x. And then when we combine the 3y and the negative 3y, those kind of cancel, or they add up to 0. And then we have the 6 and equals 9. Oh, look. We only have one unknown in this equation, x, so we could solve for this. So let's solve it real quick. Let's subtract the 6, so we'll have 3x equals 3. divide by 3, and we see, oh, x equals 1. So we have solved for one of our unknowns. So we'll just write this up in the top right corner, x equals 1. Now, let's take that value of z and substitute it into the third equation. So we'll put that in green. All right. So again, we're going to take that value of z in blue, and we'll substitute it into the other equation. All right, so I'm going to erase all of this. And this showed back up, so let's erase that so we can write there. All right, so we're going to have 3x plus y minus 4 times z, which, remember, z is negative 6 minus x plus 3y. Okay? And let's solve. So we'll have, we could distribute the negative 4, so we'll have 3x plus y. Negative 4 times negative 6 is positive 24. Negative 4 times negative x is positive 4x. And negative 4 times 3y is negative 12y. And all that, again, equals, for the third equation, 31. Okay, let's combine terms. 3x and 4x is going to be 7x. Y and negative 12y is going to be negative 11y. And then plus 24 equals 31. We could subtract the 24 over, so we could get this to be a little bit simpler. And I realize my face might be over this. So we could take that equation, we could subtract the 24, so we get 7x minus 11y equals 31 minus 24 is 7. Okay, so we have an equation here with two unknowns, but remember that we know, what x is. Remember, we solved for x a second ago, so we can substitute in x into this equation to figure out what y is. So let's look back at what x is. X equals 1, so let's substitute that in here. So we'll have 7 times 1 minus 11y equals 7. Okay, so 7 times 1 is 7, minus 11y equals 7. We can subtract the 7, so 7 minus 7 is 0, so we'll have negative 11y equals 0. Divide by the negative 11, and we'll see finally that just y equals 0. Okay, so there's our second unknown, our second variable. So our second variable is going to be y equals 0. Now we can take both of those unknowns, or we can take both of those solutions for x and y and substitute them into one of the original equations to solve for z. So let's do that. I'm going to erase some of this to give myself some space here. Okay. And let's erase this again. And let's do this. Let's substitute it into the second equation, the original equation. So we know x is 1, so we'll put a 1 in there. Minus 3 times y is 0, plus z equals negative 6. Okay, solving for z, let's go ahead and simplify. 1 is just 1, minus 3 times 0 is just 0, plus z equals negative 6. 1 minus 0 is just 1. And can we take that? So we'll have 1 plus z. I'll put a little cross there so you can see it's a z equals negative 6. Can we take the 1 and subtract it over? So we'll have z equals negative, that's supposed to be an equals, not another z, equals negative 7. So there we have our last one. So we can write that right here. Z equals negative 7. Z equals negative 7. So remember what your rules are, guys. Way up here, your steps. solve one of the equations for one of its unknowns, and then take that and substitute it into the other two, solve those two equations, and see if you can get solutions, and then take the two solutions you get, substitute them into one of the original equations to solve for the third variable. All right, so really it's just kind of like working it out. It's kind of like a puzzle. You're trying to get one solution at a time, and you're just trying to do substitutions to figure out what one of the variables are, and then once you figure out one, you can substitute it in again, figure out more. It's really a big puzzle. I would say, guys, best way to do this, best way to get good at this, is to start practicing, start doing it. This is going to take a lot of practice, but try a few, and let's see how you do. All right? Y'all have a good day. Thanks for watching, and I'll see you in the next video.